Hello everyone, my name is Avkash, and if you ever wanted to download a self-driving or an autonomous car dataset coming out from its various sensors such as LiDAR, camera, the actions taken by the car itself as well as the various metrics, so get all that data and you would want to visualize that data on your local machine exact similarly the way the AI engineer or the autonomous engineer visualize that data and understand what does the car see. This tutorial is exactly for you. In this tutorial, we are going to do two main things. First, we are going to download the XVIZ Protocol transformed data available from open source websites, and then that data is downloaded locally. Then we are going to consume that data into the Streetscape open source project so we can visualize all that data. You will have opportunity to work with NuScenes as well as the KITTI dataset in this project. I have a list of steps we are going to follow, and all those steps are documented at my GitHub repo. So it will be very easy for you to follow because in this tutorial, I'm going to follow all those steps in front of you. So when you are going to perform those steps on your local machine, so you will have my guided tour in front of you. I made this tutorial very simple for you, so it becomes very easy for you to download this XVIZ Protocol transformed self-driving data on your local machine and visualize it without any problem. So let's get ourselves started. So before we start our workshop or tutorial here, let's spend some time to recap what we have covered in the previous tutorial. If you have already covered it, please jump to next chapter. In previous tutorial, I showed you how you can use the publicly available avs.auto website and you can visualize the KITTI dataset as well as the NuScene dataset as provided within the XVIZ tutorial. There are two things to learn from previous tutorial. First, the datasets are transformed into the XVIZ protocol. So original datasets are transformed using the XVIZ protocol, and the converted data is in the form of XVIZ protocol transformed data is used by the Streetscape.gl open source package to visualize various information related with the autonomous data, sensor, actions, metrics, etc. etc. Now we are ready to start our tutorial in this video. So all the steps related with this workshop or this tutorials are already available here at this Streetscape.gl demo folder in my DeepWorks GitHub repo. First thing, you need to familiarize yourself with the Streetscape.gl code. So open source, Aurora open source, they are the one who actually took over the Uber self-driving division. So Uber is still own about 40% of this company, and the technology is all owned by Aurora. So we can look into the Streetscape.gl. You need to download this code or you need to clone the source code for the Streetscape locally on your machine. The idea behind Streetscape.gl is to visualize the autonomous and robotics data using the XVIZ protocol. So XVIZ protocol is also part of Aurora open source or the Uber self-driving kit. You take all the data coming out from logs or the autonomous self-driving car system. So you have sensors data, you have metrics data, and you have actions. The car is taking actions, turning left, right, slowing down, accelerating, whatever action shall be applied. All that data has to be transformed using this XVIZ protocol, and the output data has to be fed into in this system, which is the Streetscape system. I have already cloned the Streetscape.gl repo locally in my machine, and we are going to look into the examples folder. Within the examples, we need to go to the get started, and that is the base code for the Streetscape examples of using a pre-transformed XVIZ protocol data. So you need to run the npm install, and it's going to install all the packages required for it. I have already done. That's why this node modules is created. Let me run one more time for you. After that, you just need to run the npm start. Once the npm starts ready, the server automatically gives you the data related with the KITTI dataset, which is this dataset. However, here the data is already transformed into the XVIZ protocol format, and all the streams related with the data is available here. About 15-second worth of data, which include 155 frames, are available. You can play this data. If you would want to change the perspective, here is the top-down view, here is the perspective view, and here is the driver view. You can also enable the tooltips. Let me use the perspective view, and here you could see what the object is: van, car, pedestrian. Those objects can be tracked like this way. This is your self-driving car. If you would want to adjust your view, you can actually press the shift button and use mouse to change the view. Now you see that I'm actually able to shift the view. This data also has the acceleration, velocity, wheels. All the metrics related with self-driving car are also available, as well as the camera view, and images are being updated, and this shows us the view of what the snaps or per second snaps are created for this user. And if you can match also very quickly that this is the bicyclist is actually moving here, and this is the cyclist and the car here, so you can get an idea what you are seeing. Now we need to look into the data. Let me pause it. That when this page loads up, and it actually reads this data from example log. This example log is actually coming out from one of these three different files. One is if you are getting all the data from stream. Second, you are getting from live or from the file. We can look into the XVIZ design. So you have three different ways to send this data, either live or through streams or through the file system. So this data is coming from the file, and it's reading the default data. So we can look into this log from file, and this log from file is sending this default XVIZ file loader. And here you can see that the 0 frame is the timings file path, and this is just a JSON. So if you take this file and open it here, you will see that these are the frames, which about, you see 151 frames. These are the different frames. They are the frames which are loaded here. So these are the frames. So that frame JSON actually gives the details about each frame. After that, the file path, all these GLB files, these are the XVIZ protocol converted files. They are also being downloaded when this application loads up. So if you try to reload it, and you will see that these different files are being loaded here. And let me show you the network, and I will reload this page. And as you see here, these frames are being downloaded right now. And as the frames are being downloaded, you could see that this progress bar is also being updated. So these frames are being downloaded when this page loads up, and that is because of these two code. They are being used here in this when the example log, the default XVIZ protocol file loader is used. So that is very important for you to understand. It means if you would want to automate this code to send a different XVIZ file loader, you will have to process it here. Rest of the code has these constants related with the mapping and then the tracking, all these tracklets what we see. They are all defined in this constant. And if you look into the file, it's really very simple. There are three main files. One is app.js, second is constants, and third is either these. So if you want to have the data coming out from either file or from live or from the stream. So these are the different way to get that data. As you see here, stream is coming out from this HTTPS and it's a WebSocket. Here, if you look into the live, again it's a WebSocket. Our focus is all about directly from local file system, and rest of the code is just designed here, which actually renders these properties. So now you have got this idea where the frames are being loaded. You can see that this is the place where the metrics are rendered. Here are the images rendered, and here are the tricklets, you can call them, or you call them streams, are rendered here. Here is the log viewer. Here are the head over display HUD, and here is the log metrics or log the times frame. If we try to look into this here, as you could see that this is where it is, the matrix panel left, camera view, he is there, the settings are there, and finally these are the tricklets, so stream settings. Finally, this is the log viewer where you could see all the map. Then here's the HUD, which is like a top right side, and the metrics widget, and these two, and then finally is the playback control. So looking into this, this is a playback control, this is the HUD content, here is your log viewer, and rest of the data. So if you would want to instrument this code, you will have to have understanding of these as well. So once you have seen this code is working, now our objective will be to instrument this code and use our own data. So here we have KITTI dataset. Here we have the NuScene dataset. So it's a very old dataset, version 0.1. So in this tutorial, I will be helping you to get the XVIZ protocol converted data for both KITTI as well as the NuScene first. Then we are going to instrument the same code which we have seen here, so that we could load either of these two datasets. Let's come back to DeepWorks repo. So first, we have already seen here, we run the npm install. One thing you need to make sure that you have to integrate the Mapbox token in your code. So here in .env, I already have this Mapbox token embedded here. So when this code runs, it reads this Mapbox token and it processes it. If you do not have Mapbox token is read here and it is defined here. You can actually copy your Mapbox token directly here, and then Mapbox token will be read easily. If you do not want to create the .env file where the process.env, the React component will be used to read the Mapbox access token. So this one we have completed. So step one, you got yourself familiarized with the Streetscape.gl code and the example which we have covered. Now in the second step, we need to get this data. It means we need to get the KITTI data frame, and all here you see frame JSON, and here all the GLB files. Here for the NuScene data set, we need to get these frames, and we also need to get these 390 frames for the scenes. So here we do not need at this point. I will close it. I will just go 2 level back, and here I will create a folder called workshop, CD workshop, and here we are going to create mkdir KITTI, CD KITTI, and wget. So we have got this frame. Then we need to get all these files from here, because we are using here parentheses, and here you could see 1 to 155. It will download all 1 to 155 files. We need to fix this. Make sure you fix these parentheses. After that, when you copy it, now these files are being downloaded. So all 1 to 155 files will be downloaded. So here I have downloaded the both KITTI and both NuScenes data set as suggested by here. All these files are downloaded. I will show you the NuScenes. It's a I have created a folder called 0.1 and all the files are downloaded here for the new scenes. So after we have downloaded this XVIZ transformed KITTI as well as the new scenes dataset, we need to use this get started folder, which is actually located here. Get started. So what you are really reading is the same place. So you need to get this get started code, and we need to create our project something look like this. So here is the DeepWorks repo, and here is the self-driving tech, and here is this demo Streetscape, and here is our get started. Here is our get started folder. This we need to take this and copy. Get started folder is available now. So that is our get started folder. If we go back, we have KITTI and we have NuScenes data, so we can move. So move KITTI to get started, move NuScenes to get started. So we have KITTI and we have NuScenes, they both data sets. We can go KITTI, and this whole data set we have to put inside if a folder. This we can say mkdir a folder mv star.json to 2011 folder mv all star.glbs to 20. Now that's only one folder left, 201126. All the files are here. Similar to KITTI, if we validate new scenes, we also have the same way new scenes. And if we look into the v01 and all the data sets, so we can match. So we have index.html, we have KITTI, we have new scene, we have KITTI, we have new scene, we have src, we have package.json, env, we need to add it, or we can add this mapbox token directly there, and package.json. So we have almost everything ready. Now what we do is that we need to load this whole code into the Visual Studio IDE. So let's load this code. Creating new window, autonomous workshop, get started. Here is our src. I will give you a quick update about the package.json, which project which is get started in Streetscape demo, which I have created. It's using React 17. It also using the latest React as well as the Chakra UI 1.7 version. If we look into the Streetscape get started project examples, get started, you will see that this is really very old project. It's using the React 16 and it also using the React Streetscape version 1.0.0. But it's about a quite old project, about 3 years old. So the project what we have here is a latest React as well as it's also using the Chakra UI. Here I already have this code loaded into Visual Studio Code, and as you could see here, this data is coming out from autonomous folder workshop get started package. So this is the exact package.json related to our project. Here the app.js, it's actually changed totally. Rather than using the div, it's actually using the Chakra provider, and everything is based on Chakra. And in the file section where we are loading the files, we are reading these new scene data, and we are also reading this KITTI data, and these two data sets are exported here. We look into the app.js, and here the app.js, we have the log KITTI and log n, and using select option, we choose whether we want to see the KITTI data set or we also want to see the new scenes data set. So here we have already mapbox token is added as a constant here. Perfect. So our code is almost ready with this new mapbox token. So let's run the npm install. As you see here that we do not have the node modules added here, so we need to run the npm install. After the installation is done, we can validate that node modules folder is created. Next, we just need to run the npm install. Now npm run is started, everything looks ready. We can come back to our browser, open a new tab here and run localhost 8080. By default, it comes with both KITTI and both NuScenes dataset, and that is because we already have that code implemented in our this get started project. We already load the KITTI data as well as the NuScenes data as defined in this log from file. So make sure you understand, make sure you get an idea that the data, these folders are coming within the project. So if you see here, the KITTI dataset is coming out from this folder and NuScenes dataset is coming out from this folder. So once we have these two folders are read properly, and when this application is start, all those files are available in the memory. Next, we have this drop down where you select whether we want to use the KITTI dataset or we want to visualize the NuScene dataset, and based on that selection, all of those datasets are updated based on your choice. When we see NuScenes dataset, here we have NuScene dataset available. When we want to see the KITTI dataset, we can select the KITTI dataset, and they both are directly loaded into the memory, so we don't really need to download them again and again. First advantage. Second, there are few differences. If you see the KITTI dataset, it has the map information, so we get the background map. We also get these metrics, means the acceleration, velocity, wheel. These data is also available. If the driver is making, left or right turn, they could be highlighted, or if the system is able to recognize the red, yellow or green light, that can also be visible here. Stream object, here you could see that variety of objects are available with the camera, lidar. Here the camera views are available. Last camera, you can see there is a color image, so color and gray image are available. Views are available, driver view, perspective, as well as the top down view. And here you can also use the tooltip. So when you try to move your mouse, you can get tooltip. So that's the information you are getting from the KITTI dataset, which is coming out from here. Next, if we change the dataset from KITTI to NuScene, which is coming out from here, this is the old version dataset because I'm just using the pre-created XVIZ protocol data. So that's why we are using this old dataset. This dataset does not have the matrix, that's why this area is empty. It does not have the map data, so that's why we do not see the background map data. It does have a lot more streams. It means a lot more tricklets are available. So here you could see types of vehicle, you can see the boulder, you can see the moving car, you can see the cone, human, pedestrian. A wide variety of data can be seen through this dataset. However, this dataset does not have other things available. If you would want to change these maps, for example, light to dark, it will change the dark map. If you would want to make change to light, map can be changed in real time while your view is still available. And I have added this in a way that if somebody would want to extend this project to even more details, they could extend it. Let's take a look at the code very quickly. As you could see here, I'm using the Chakra UI. If you are not familiar with Chakra UI, I would suggest you to please look some of my videos about Chakra UI. I love this UI layout framework because I don't really need to write the CSS. It automatically takes care of all my CSS work directly within the code. Chakra UI, these are the component. Here I'm creating a horizontal stack which has two components. So horizontal stack has a one component, two component, and then I have this vertical stack where I have this tab. So I generate these vertical stacks. These are the area, and then here in this vertical stack, I have these two, log viewer and the playback, and finally this HUD is also built into within the log viewer. Let's take a look at the log. Here you could see that I have these two tabs, dataset view and settings. In the dataset view, I have these vertical stacks component. Then the right side, the another one vertical stack. At the very top, we have this log viewer, and within the log viewer, we also have this HUD. So these are the HUD component, and the bottom we have this playback control. So which is this code is being broken out from the previous one, app.js. So this is the older one, just CSS and the div and these XVIZ or these Streetscape components which are defined here to render the data. So that's a big difference between the older code and my code, because I decided to give the latest layout. So if somebody would want to enhance this code, they could enhance it very easily, because this is a fully working code using React 17 and the Chakra UI version 1.7. So at this point, I believe that you have very good understanding of running this code, which is available here in this Streetscape.gl demo. As you see here, all these steps which we have followed in this tutorial, so there should be nothing surprise for you. So I believe is that after watching this video and following through this GitHub repo and the instructions available in this README file, you sure will be able to run your own version of Streetscape demo running on your local machine. If you have any problem, please either respond to me at this GitHub repo, or you can respond to this YouTube video, and I will be very happy to assist you. So before we go, I just wanted to give you the details where this whole project is located. So please visit DeepWorks repo, and in this self-driving tech, within this self-driving tech, this is very first project. It is available in this Streetscape.gl demo. All the instructions are available here. Step 1, familiarize yourself with the Streetscape.gl code. Second, get all this XVIZ protocol transformed data for this KITTI as well as the NuScenes dataset. And finally, use this get started project which I have created and follow these steps to install all those packages required for this project, and finally run it and enjoy this demo. So combining my two tutorials, one previously and second this current one, now I believe is that you have very good understanding of what it takes to visualize a self-driving or an autonomous car data on your local machine. The next tutorial is going to cover how to transform the actual data which is coming out from these cars and learn how to transform that data into the XVIZ protocol. Because in this tutorial, we have used the XVIZ protocol transformed data within the Streetscape.gl. So we did not understand how the original data coming out from various sensors, LiDAR, radar, camera, actions made by the autonomous car robotics component, all that data has to be processed properly using the XVIZ protocol, and then the output of that protocol data is what we have used in the Streetscape.gl. So next tutorial is going to exactly take you the KITTI dataset, and we are going to perform the XVIZ protocol conversion on the KITTI dataset so that you can use the generated output and you can feed the data into the exact same project what we have used today. So that will be part 3 of this autonomous driving tutorial. Thank you so much for your time. I do appreciate it, and I'm looking forward to seeing you in my next tutorial. Until then, thank you so much.